We've got to move the conversation away from pure economics, where everything is couched in terms of, oh, what's that going to do with the economy? And move on. There are ways to deliver greater well-being for humans and greater well-being for the natural system. And the industrial system is the intermediator between those two, and it can do both of those things.
I'm Ranjor, and this is Remake, a podcast about design, systems, and society. In each episode, I talk to someone who's trying to change our lives for the better in some meaningful way, whether through a new product, new venture, or a new way of looking at the world. And I try to understand how they came to it, what makes them tick, and what we can learn from them. Professor Steve Evans leads one of those fields that sound boring, but are actually super critical to our world and our future. He's the Director of Research in Industrial Sustainability at Cambridge University, where he leads research that helps factories become sustainable at scale. He helps industry bring about sustainable change at scale, including business model innovation, system transformation, and helps push the limits of efficiency in both advanced and developing countries. Steve has over 30 years of academic experience and spent over 15 years in industry, where he led groundbreaking projects with Airbus, Jaguar Land Rover, Nissan, Electrolux, Toyota, as well as the city of Porto, Portugal, among many others. In this conversation, we talk about what he learned from his early interest in martial arts, how his time in both academia and industry helped him think about the right relationship between the two, why industrial sustainability is so crucial for avoiding catastrophic climate change, and why it also represents an enormous financial opportunity, how to make making itself more sustainable, what the shadow of a bike is, and why we need to think about the sustainability of products we buy as larger than simply the materials used in their making, what his vision for industry in 2050 is, and what are some of the most promising development he's seen in this field. This conversation is one of a dozen or so weekly conversations we already have lined up for you with thinkers, designers, makers, authors, scientists, entrepreneurs, and impact investors who are working to change our world for the better. So follow this podcast on your favorite podcast app, or head over to remakepod.org to subscribe. And now, let's jump right in with Professor Steve Evans. All right, I'm sitting here across the screen from Professor Steve Evans. Steve, welcome to the podcast.
It's really good to be here. Good morning, good afternoon, good evening.
So we have a lot of great topics to cover, but these days we usually start with a COVID check-in. I'd love to hear where in the world you were when COVID hit, its effects on your life, personal life, work life. Where do you stand now with the pandemic?
I was actually in northern Italy when all the chaos started in northern Italy. So
Wow.
it was really quite profound. And my wife and I were taking note. And as we got to the airport, we found masks and we got on a coach. We were on a skiing holiday. We got back to the airport. We were the only people amongst 10,000 people from northern Italy who were wearing masks. 9,998 are just going as normal. Now this all seems a little bit strange. Why didn't we behave differently, really, at the start? And then we remember the chaos of those first weeks and months. There's less chaos now, and maybe we're getting very used to it, but I don't know how the rest of you feel. I think we're all pretty exhausted. And I think that the mental well-being dimension doesn't have enough prominence. We're not finding answers. We're more worried about the economy. Yes, it's good that we're worried about physical well-being, but I think we need to be as worried about mental well-being, maybe more than we need to worry about the economy. That'll pick up again. I'm from Britain, right? Britain is great, apparently. So I'm not going to talk about my politicians or I'll never get my passport back.
Yeah, it was very interesting to see how different countries reacted, how different people reacted.
how I reacted when I knew different things. So I was definitely in February still flying back from the UK, not wearing a mask, surprised that everybody around me were wearing masks. And 2 weeks later, we were all sent to our homes. And that's when I think I started to take it seriously, is when things really got serious. I started listening and learning. It's also remarkable to see the difference between someone who has friends who are scientists and doctors and someone who just in their circle does not have these people, and how different their view of reality can be. If all you're taking as an input is like Facebook or news you see online.
I think the delineation between Group A and Group B, one group you've just suggested, people who have friends who are doctors and scientists, and another group get their data from Facebook. I think it's probably has much greater subtlety than that, the delineation between the two groups.
Sure.
I would offer an interpretation that says Group A and Group B. There's Group A are people who understand and rely on the scientific method. They are able to tell the difference between a good experiment and a bad experiment, and therefore tell the difference between good data and bad data, data you can trust and data that you question and you think it's a number, but where did it come from? Who said it? And where's the root of that? And how did they design their experiment to come up with that number? If you have the scientific method as a basis, I think you ask better questions of the news. So for me, Group A and Group B have their origins in confidence and competence in the scientific method. And sadly, too many people don't have that. And therefore, they don't even understand that they're relying on a subset of information. I have a particular political ideology. And I'm constantly given news that matches that. So it's not going to shift.
Right.
And you have to work harder and harder in a world of narrowcasting to go and listen to the news that other people receive. And when you go there, sometimes it's incredibly shocking. Well, if I was given this information, constantly bombarded with it, I might believe a very different ideology. I think walking a mile in other people's shoes is going to become ever more important as we have increasing narrowcasting globally.
Yeah, that makes a lot of sense to me. Did COVID have any effect on your work, or was that pretty safe?
In terms of health outcomes, the University of Cambridge has been very cautious and very safe. But one of the ways in which we've implemented that, I did not go to my office for 18 months. That's a very long time. And if you talk to the president of my college and ask her how science works, she will absolutely tell you science happens in the bar. It's where you bump into adjacent ideas. And then that makes you think hard about your own ideas and you go off in a slightly different direction. That experimenting requires the serendipity, the proximity to other people's thinking and ideas. And I think you can get away with not having that for a season, for 6 months. When we're now without it for 2 years, and it's beginning, I believe, to take a toll on research quality as well as mental health, but we'll recover.
Yeah, it's a fascinating thing. And I've been hearing similar things from other researchers. I wonder if there'll be 10 years from now, a dip in the results of these studies. Suddenly there'll be a gap. So we have this opening question that we like to ask to start exploring the story of the guest. And that's, what's something you learned in childhood or early in life that's still with you today, that still guides you today?
I'm going to take my time in answering that question because it's actually a quite important question. I've not answered it before, so I am not just hesitating for effect. I'm actually thinking. And I believe that what I learned was never taught in a directed way. Nobody stood in front of me, neither my parents nor my teachers, and said this as a statement. But tenacity. If you keep going, eventually you can travel long distances. It's not about the speed, it's about not stopping. And immense success can come from absolutely pure tenacity. it is annoying when you see other people with tenacity. It just doesn't seem fair. They seem to achieve things. Yes, it's because they don't stop. Yes, they hit a bump
Right.
and it slows them down, and then they come back again tomorrow. And if there's one great lesson that I picked up, it's just that one, tenacity.
Interesting. And can you give me the background for how you learned this lesson? How was it present in your early life?
I'm very bad at a lot of things, but a lot of those things I wanted to be good at. Now, for some of them, just carrying on doing them and practicing allows you to become more than reasonably competent. Not world class, because you need some inherent skill, maybe. So for many academic subjects, I made myself very competent at them by continuing. I used to be in the mountain rescue team at home, so my interest in doing things outdoors, I'm not a naturally gifted rock climber, but I can do it. Just keep going, keep falling off, you get better. I'm a black belt at judo and was in the national judo team. Honestly, in the room, there were dozens of people who were more naturally skilled than me, but I just kept going and slowly got 1% better until I could compete with people who had greater natural gifts.
It's good to have someone with that sort of tenacity working on the type of sustainability issues and large scale issues that you are dealing with today, because those also require a lot of tenacity. Wouldn't you agree?
Absolutely. And when I began, we didn't even call it sustainability. It's had various names. I think the earliest discussions, we used to call it environmentally conscious design. Then it became eco-design and eventually sustainable design. So long before we called it sustainability, I was in there doing it and studying it and doing it in companies. I thought that we had about 200 years, and we did use the metaphor at the time, 200 years to turn around the oil tanker. And that my students and their students would still be working on problems to help turn the oil tank around. And that my job was to help lay foundations for something that would not happen for generations. But for every year that I've been in this world, our understanding of the science of climate, of biodiversity, of soil health, of toxicity has meant that the deadline, the date at which we have to solve problem X, has come closer by about 5 years. So for every year I've been in it, the problem's got 5 years closer. And that's an accelerant. So rather than my student solving the problem, I now find myself in the later years of my career not believing we've got a 200-year plan that we have to implement, but not even a 20-year plan. We're now down to 20 months, and it is genuinely that urgent. If we continue emitting CO2 and its equivalents at the rate we're emitting it today, we only have 7 years and 7 months before we have to turn off every car and every power station in the world if we want to limit global warming by 1.5 degrees. We've got 7 years, 7 months from today. That's the urgency. Now, if we can get off the habit, we can buy ourselves more time than that to turn off the last power stations. But we have to get off the habit. We can't continue to operate as we are today and then hope for some sort of binary change at some amazing moment in the future to that different and better system. It's massively urgent.
That's an interesting transition from thinking of it as a 200-year challenge to thinking of it as a 20-month challenge. So you talk a lot about the importance of industry for this transition and sort of this idea that the industry is at least a third of the picture in terms of greenhouse emissions. Would you like to talk about why is industry so important for this?
So when we look at how the world works, and people do different forms of accounting. Let's just say carbon and its equivalents, and climate change is the issue of the day. There are many other issues, but largely for the purposes of this conversation today, I'm going to keep referring to climate, but it could be to do with plastic, it could be to do with water pollution, it could be to do with other items. So let's take climate science. Where does all of that CO2 and its equivalents come from? And if you said, oh, it comes from cars. Yes, but if the cars are transporting things from one factory to another, is that an industrial output or a vehicle output? So categorization is different depending on how people count things in different countries of the world. We have different counting systems, and therefore it tends to diminish the role of industry. And what we find broadly is that about 30% of all CO2 comes fairly directly and indirectly. So the power stations that power industry plus industry itself, about 30% of CO2 comes from industry, about 30% comes from buildings, and about 30% comes from vehicles. And about 10% comes from direct food system. Now, if you said, what is the output of the food system, the CO2 output of the food system, you would start to count the factory emissions to make the fertilizer. And that then tells you that food accounts for about a third of CO2. But farming doesn't. It's the industrial system that provides the fertilizers, the herbicides, the pesticides. And that's why the industrial system is incredibly important. The industrial system builds the products that are the cars and the buildings. If you can get industry right, which is why I study it, you can get the food system, the transport system, and the building system also operating more effectively, more sustainably. So I've spent my life studying what I think is one of the heart of the matter problems, which is the way that we've accidentally created an industrial system. Nobody designed it to be this way. This just happened to be the way that a combination of technology, society, and money allowed it to emerge. And the industrial system of today has generated enormous benefits. When I was a young man, my mum, I would go to school on Monday morning and she would get the washing machine out and start washing. And when I came home from school, 7, 8 hours later, she was still on the washing machine cleaning the family's clothes. Well, we don't do that anymore. We just pop it in the front, we press a button. And the industrial system of the world has built those products and made them available at a price that many people can afford. So the industrial system has helped deliver the well-being that we currently enjoy. At the same time, what it didn't know it was doing was poisoning the world and grabbing resources from future generations. We've been too successful, and we need to learn to deal with those unintended consequences. And we really need to learn how to deal with that in the next decade.
You gave a really interesting name that really speaks to me, the interaction between our industrial system and the natural system. I'm really interested in systems thinking. And so that really brings to mind many different components of an industrial system interacting with many different components of the natural system and creating almost like a one super system that really we need to stay living within. So is there an aspect of difficulty of seeing the whole? So people see the parts and the real story is told by stepping back and looking into their relationship. Why aren't we better at solving these sorts of problems?
Maybe I've already hinted in a very positive way at a negative thing. I've suggested that it would be a wonderful thing if more people understood the scientific method. But the scientific method is designed to separate out variables, to identify the smallest number of input variables, the smallest number of output variables, so that we can have the highest quality of experiment and trust the results. It's non-systemic. And there's an encouragement to be non-systemic the further you go up disciplines. And I think that's at the core of the problem, as well as a key skill, which would help people deal with life, I believe, being good at scientific thinking. In practice, scientific thinking does not embrace systemic thinking. And we don't teach it. And I think that your comment about the interaction between the industrial system and the natural system, whenever we meet somebody who has given some meaningful time to think about those interactions, we tend to stay and pause and listen. We go, wow, that's really quite wise. How did they come to that? Well, they just took time to observe what is observable. But it is very difficult to observe the interactions between two massive systems. Most climate scientists, for example, are incredibly good at understanding the climate system, and they help to write the IPCC reports that warn us about the scale of the problem. But should I listen to a climate scientist who tells me what the future industrial system should do and how it should do it? Because really, they have a very good understanding of the climate system, but a limited understanding of the industrial system. So when we meet people who are polyglots, who have the skills of being good at both, we stop, don't we? We all stop and say, please, I need to stay in this person's presence and grab some of that understanding. But I think it means for most of us ordinary people, what we need is really interesting friends who understand the other systems and are willing to engage in difficult conversations where I make naive comments about your system. And when I make that naive comment, Aaron, you are smart enough not to tell me I'm stupid. What you will do is you will say to me, Steve, I'm really happy you're engaging with my world. I'm really happy that you want to engage with my world. But I have to give you a little bit more knowledge than some of the things that you've just said. Maybe not so clever, right? We have to invite people in to those systemic conversations. And that's a skill that we also see and welcome in others. When we see people like that, again, we want to sit and talk with them.
I think that's the soft skills or the meta level skills that makes so much difference in how conversations actually go and actual outcomes. So I find that really interesting. You have this concept that I really love and it plays to some of that where you talk about the shadow of the bike. So it's this really great metaphor for understanding. And I think from the moment I heard it, I don't think I will ever look at another product again. I think you quoted a stat that 10% of processed materials reaches the customer. So to make a product, there is so much waste around each and every product. So tell me more about the shadow of the bike and where it came from and how does it help us be wiser?
I'm going to call it a teacher's trick, and as a teacher and as in many walks of life, it's really important to experiment, to try different ways to communicate ideas, and some work, and you have to have your mouth open to offer that up. And you have to have your ears open to realize that one worked and that one didn't work. Well, the shadow one worked. What do we mean by the shadow? Everything that's made, every book, every cup, every coffee bean comes not just with the material that you actually see in front of you, but with all of the chemistry, all of the material that it took the industrial system to get that to reach you. And most people have no clue about the scale of the shadow. So if we take something like most ordinary products, almost everything that you're surrounded by at this very moment, the shadow will be between 10 and 20 times larger than the item. So when you buy a kilo of brick, a kilo or a pound of chocolate, there's 20 kilos and 20 pounds of material that went into making that, and 19 of it is somewhere else. You end up with the 1 kilo. And in some systems, that number is as high as 50. So when you're buying 1 pound or kilo of material, there is 49 pounds of material that is in various landfills dotted around the globe in order to get that one to you. Once you see that shadow, you start to think, really? I thought that the industrial system was remarkably efficient. The word efficiency is possibly one of the most commonly used terms. It's what we teach when we teach people to work in industry, how to be efficient. And we are remarkably efficient. We're very efficient in many ways. We're very efficient with labor and with capital. But one of the reasons why we have such large shadows of material waste is that we're focused our efficiency skills on labor efficiency and capital efficiency. And those are used efficiently. But energy is too cheap and material is too cheap. So if it takes me an extra kilo of material, but I save 2 minutes of labor, that's a price I'm willing to pay. And that's why this material shadow is so large. The labor efficiency is high, the material efficiency is low, and that's across the industrial system. I would like to offer hope to everyone who's listening. In my world, it's really easy to do doom and gloom. If you read how fast our challenges are coming rushing towards us, you think, well, if we don't deal with that challenge, some sort of major crash is going to happen. No, people are ingenious. Humans are amazing. We'll find a way through it. So what would that journey look like? Firstly, we would learn how to see that shadow, how to see that waste and start removing that and just go, maybe we are willing to use that extra 2 minutes of labor and save that 2 pounds of material.
I'm curious. One of the things that came to mind as you were talking about the shadow is I come from the world of tech, and a lot of the products that I consume are technical products like laptops and phones and monitors. And I'm wondering, how big is the shadow of those products, just out of a selfish kind of curiosity? And are there industries where maybe the awareness is higher or the efficiency is better with this shadow?
Right. Let me try and answer the question very directly. By technical products, I'm going to presume you mean products that are largely electronic in nature. So they'll have a battery or a plug, and they'll have circuit boards and integrated circuits and really interesting screens with very exotic materials in order to make them light. And whenever anybody says lightweight, they don't mean I've made it out of a smaller mountain. They mean I took the same size mountain, maybe a bigger mountain, and turned it into something that's lighter for you to use as an end user. So lightweight tends to mean exotic materials, exotic processing, which tends to mean per kilo, per ratio-wise, a larger shadow. So if you buy a lightweight product that's 100 grams lighter to fit into your pocket, that 100 grams lighter typically does not mean the shadow has got any smaller, unfortunately. No. There are no sectors that are particularly amazingly good, by the way, to answer your second question. If we look at the clothing sector, if we look at the long-lasting goods, things like ceramics last a long time. So in some ways, that's a better sector in terms of the shadow for your lifetime compared to things that are one-off or multi-use products. But the shadow to make one ceramic item is still very large per item.
Yeah, that makes a lot of sense. So this reminds me of, by saying that we're pretty efficient with money and labor, what I hear is we are optimizing for money. And that brings to mind, I'm trying to remember where I read this, but I think I saw some proof that if you optimize for only one metric, by definition, over time, you're severely hurting the other metrics, that there's a decay involved. Is it that the industrial system is running an algorithm that's just optimizing for one thing instead of optimizing for some sort of balance of multiple variables?
I think in the way that you phrased the question includes the answer. You commented really on two dimensions: optimizing for a single variable, and a consequence of that is over a long period of time, what happens to the other variables? So if we optimized for money over a long period of time, we might not have the same unintended consequence. So that begs a question. Is the issue not the optimizing for a single variable, but the lack of optimizing that one variable over a sufficient period of time? If we optimized for money over centuries, we would not destroy the basis on which that money is made. We are destroying the natural capital, which allows us to create the economic capital. That is financially stupid. In the long term, it's financially sensible in the short term. So I think that there are two confounding reasons why optimizing for a single dimension, financial efficiency, in the short term is a bad idea. One is that the short term versus long term issue comes back to hurt you. And the other one is that optimizing for one dimension and ignoring the others inevitably results in the other dimensions eventually coming back to hurt you. So
Yeah.
I would agree, optimizing for one dimension is a problem, but also a partial solution would be optimizing for that dimension over a sufficiently long period that it inevitably re-internalized costs that in the short term it can afford to externalize.
Yeah, this is really interesting. So there's a couple of stats that I heard you mentioned. So the one I mentioned before is 10% of processed materials reaches the customers on average. Only 50% of food is actually eaten. And you mentioned in the UK, 27% load factor in trucks overall. So we're wasting the emissions of these trucks. And then you presented this vision for the industry by 2050, this very ambitious set of goals. You'd like to talk about how that emerged and how's that going?
So before we had this rather modern phrase of science-based targets, which says we should decide our targets by understanding ecological limits rather than by understanding what is the limit of the current system. The ecological limits that are imposed on the industrial system tell us that by 2050, the industrial system would have to produce more value. And the reason for that is that we will be helping more people have a greater well-being, not a greater GDP, but a greater well-being. They will have healthier, better lives. And factories and products coming out of factories are necessary to deliver that. So factories will deliver more value by 2050, not GDP, different conversation. But scientifically, we've got to do that with zero carbon emissions, zero climate change impact. And broadly speaking, we have to halve our material intake. So the industrial system needs to cut down half of the amount of wood, half of the number of mountains that we cut down. Now, if we are trebling the value we're delivering to people, but halving the material intake, that's a very significant change. That's not a minor change. And we are going to move to zero greenhouse gases. So those are very significant shifts.
Yeah.
Can it happen? I'm absolutely confident it can happen. Will it happen? I don't have the same confidence that it will happen because the ability of complex human systems to tackle problems of such scale is low. Our governance systems, our coordinating systems are obviously failing us. We've just left COP26 recently. The governments of the world have demonstrated that they are not capable of coordinating themselves in the face of an imminent disaster. They're going to wait for the disaster to happen before they can bravely ask their citizens to do things that are good for the citizens. While I believe it's utterly possible to do something, that does not mean I believe it's probable.
I'm thinking of myself if someone came to me and said, Iran, you have to design 3 times the number of products you've designed so far, and we're going to pay you half as much as we paid you so far. And by the way, here's a set of tools that you really can't use anymore. It would be hard to hear.
So it is a big deal, but I'm going to take you up. I didn't say pay you half. I think that by definition, if the factories of the world are producing 3 times more output, there's more good stuff to share. The quality of our lives moves forward. And I'm going to be blunt. If the quality of your life was moving forward, does it matter how many dollars it takes? No, it doesn't. And we've got to move the conversation away from pure economics, where everything is couched in terms of, oh, what's that going to do with the economy? And move on. There are ways to deliver greater well-being for humans and greater well-being for the natural system. And the industrial system is the intermediator between those two, and it can do both of those things. It cannot achieve that easily, maybe at all, within the current norms of a Western economic system, where we expect GDP growth to occur every year. That's simply not possible because that mechanism encourages a linear material system, an extractive behavior rather than a restorative behavior.
Is there any hope in the realm of governance or any initiatives that are worth talking about that could make a difference?
I probably come across at least one or two new initiatives every week. I wouldn't want to predict that one of them is going to become more important than others, but the sheer fact that they're happening is the beginning of a revolution. If we went back 10 years, those initiatives were not appearing at this rate. So what we're seeing is the beginning of a period of, I believe, a very serious experimentation. People experimenting with new ways of inventing things, new ways of cooperating, new ways of governing, new ways of managing land, new ways of making things. And as we know, a lot of those experiments will fail, but maybe some of them will succeed, and we'll see very large incumbents who find experimenting difficult, we will see them disappear. If you go back 100 years in the Dow Jones Index, you would not recognize the top 100 names. They don't have to live forever. And that clock speed, as we know, is going up. It may soon be true that if we go back 40 years, you won't recognize the names in the Dow Jones Index. And that means that we're getting a complete refresh every few decades. That means that serious change is possible. And the next serious change has to be shaped to match the limits of the natural system. So it's going to be shaped in a very different way than the ones that have been previously shaped by industrial revolutions, where new technologies emerged, and we eventually worked out how we would take advantage of those new technologies. The next revolution is shaped by demand. It must change shape rather than by supply. We've got a new technology. What the heck are we going to do with it?
You're listening to Remake, a podcast about design, systems, and society. If you're listening on a podcast app, you already know how to follow podcasts. So please follow this one. If you're listening in a browser, just go to remakepod.org to find links to all the major podcast players where you can follow our show.
So you deal a lot with eco factories and the future of the factory. This is a topic I know very little about, but it's exciting to me, especially maybe even rethinking what a factory even is. Maybe it's something smaller. Maybe it's something that can exist in your neighborhood. But I'd love to understand more what's happening there. What are the trends? What are some promising development? Anything that you can tell me about the future of factories?
Yet another great question. In the next 5 years, that's how urgent this is. I don't think this will happen, but I do believe it's utterly possible. If I had a dream, in the next 5 years, every factory in the world would be able to see its own shadow, to see the waste that it produces, to get to its own end product, and would put the same vigorous, competent skills to work to do that shaping of material efficiently, the same skills that they currently use to make sure that labor is efficient. We believe that if they did that, they could improve their profitability. They could put money in the pocket for the rainy day that is to come afterwards. But we also believe that they would significantly get us on the pathway that is actually the 1.5 degree pathway, because there is massive waste in our current systems. When I go and visit factories, especially factories that make the same thing, exactly the same thing, day after day, after day, after day, I ask them, in terms of CO2, in terms of energy, what is your best day? And what's the difference between your best day and your worst day? If we take something like cement factories, which is one of the most climate change important sectors, it's the second biggest emitter of CO2. So they're really competent at this, you would imagine. The difference between the best day and the worst day is 100%. Now they're taking the same raw material through the same machine to make the same end product. Why can one day be twice as bad as the previous day? And what I would like the world to do in the next 5 years is learn how to have more good days. The air would be cleaner, the water would be cleaner, the world would be on a pathway to 1.5 degrees. So that's a beginning of a journey, and it enlightens us by seeing things differently. It enlightens us and encourages us to go learning for other things. And that's where the more significant changes are going to come through. So let me make just a couple of points about what future factories might look like. There's going to be much more biology than chemistry and physics, less bashing of materials and much more growing of things. At a simple level, we will, instead of cutting this lovely table that I'm sitting at, instead of cutting it down from a tree, we'll grow it in a wood factory, right? And it'll be made of cells that would have been wood, but we'll grow it in a factory. And we'll have no waste wood because we'll grow it into a mold, right? And it'll be a wonderful wooden table. But equally, we're going to take many of those plastics. Plastics has dominated the world. It's the great chemistry sector of the last 100 years. Initially, it was a byproduct of the oil industry, and now it's an absolutely dominant sector. That will disappear. It's simply going to disappear, but it'll be replaced by biologically created molecules largely, and by electrically generated molecules. So we'll have biochemistry and electrochemistry rather than what we currently have, which is organic chemistry, hydrocarbon-based chemistry. But let me draw two pictures for you. And one is a true story and one is an imagination. So the true story, in Europe, there is a company that makes cleaning product called Ecova, and they base their raw ingredients largely on plants. So they don't use minerals and hydrocarbons to make their shampoo or their carpet cleaner. So they're pioneers in that. And they were considering putting up a factory on the island of Mallorca, which is a tourist island in the Mediterranean. A lot of cleaning on tourist islands. But you also have to ship a lot of goods there. And when you're shipping cleaning products, you're actually shipping a large amount of water. So they thought, let's build a factory on the island. And this is where it gets cool. They thought, why don't we send a satellite over the island? The satellite will be able to combine with weather data. We'll be able to predict that farmer Iran will have his orange crop ready next Thursday and will make 1,000 liters of orange juice. And farmer Steve will have his crop ready next Wednesday. But the same prediction allows us to know that next week you will also have 1,000 kilograms of orange pulp left over. Now we have a list of all of the waste from all of the farms on the island for next Wednesday. This is where it gets really clever. Now we send it through the AI mechanisms, the AI search algorithms that look through the database of 40 million possible chemical reactions. And they find a way of taking those 5 ingredients and turning it into that end point. So now you go and collect waste from those 5 farms. You add some enzymes, some chemical processes, and you've got shampoo for free raw material. The reason I'm presenting this image, one, I think it's a beautiful image, right? Where did the raw material come from? We didn't cut down a mountain. We didn't pump up oil from under the ground. We didn't even have to dedicate land to grow it. It's a byproduct. And it seems a little bit like we're going back 1,000 years in the way that we're thinking. But we're doing it with artificial intelligence and with satellites. Now, I'll make a second point about the future. We already know that factories are too big. Actually, not emotionally, from people who observe these big buildings as they drive along roads. We can see it in the data. You know, the biggest steel factories are not being built now. They were built decades ago. Steel factories are getting smaller. So it's not true that bigger is always better. If that was true, there would only be one factory in the world making whatever it was. Books, coffee cups, There'd only be one factory in the
Right.
whole world doing that one thing, and everything would flow there, and all products would flow from there outwards. So if that's not true, then what is the optimum number of factories? And the suggestion I'm going to make is that right now we're getting that number too small. The next wave of factory technology, the machines in factories, are smaller and still profitable. So I think by 2050, there'll be a factory at the end of your street. And in fact, instead of you going, oh, really? Why would I want one of those? Let me draw a picture. In this factory, the waste from the street goes in. It's the raw material for the factory. And it's using massive intelligence to work out how to take that waste and turn it into the products that the street needs. The air coming out of the factory is cleaner than the air going in because it's got machines and it can do things like that. The water coming out of the factory is cleaner than the water going into the factory because it knows how to do that. It's a place where it can process large quantities of things. So that type of factory you will want at the end of your street, and it will become more redistributed. So there is hope.
Yeah, that's a lovely picture and something that in the end, if it is also more efficient at producing whatever it is producing, will probably happen pretty organically, right? So, we have a lot of designers who listen to this podcast, and I know that you've been involved with sustainable design. I'd love to hear what role you think we have as designers in this world, and what good can we do? And, how do you think about sustainable design today?
Well, I did help set up the first masters in sustainable design in the UK because I believe designers are very much at the center of this. So there's two things. Designers are largely intermediaries between the industrial system and the consumers. I think the designers are not as welcome as they should be in the industrial system, but equally, they're not as welcoming. And I think it's really important that designers learn how to listen to industry as well as speak to, but how to listen to people who have interesting processes and process knowledge. Because with that knowledge, they can actually develop far more fantastic future solutions. So I think that intermediary role actually requires not just listening to consumers and predicting ahead what consumers might want, but also listening to industrial systems and predicting ahead. If we design things and go in this direction, we are sending a signal to the production system that we want that system to change as well. Because these are products that are sellable, that people are making money from them, and the industrial system will adjust and move towards it. Far too often we see the industrial system go, well, we're not going to go in that direction until the customer asks us to do it. And actually, customers don't ask. I think designers can ask. So there's a very central role. If we want to reshape the industrial system, designers can be the proxy customers for that. So very important that we get the fantastic ideas from designers coming into the industrial system. Of course, at one extreme, the opportunity is to be incredibly radical. To draw the picture that I was just drawing, that maybe in the future, your clothing is going to be made from waste materials that come from the household bins of your street. Now, how close is that? I'm a visiting professor at the Royal College of Art in London. We are actually working on a project where we are taking waste material from the street, from your household bins, and extracting the cellulose to turn into garments. It's a pure new material. That technology exists at lab scale. So if we as designers can turn that into absolutely gorgeous garments that people aspire to, then we're already sending the signal. We as consumers want to go in that direction. So you as the industrial system might want to consider investing in being ready to go in that direction. And that's why designers are really key intermediaries in this long-term transformation. The word is in there. It's design, right? The transformation isn't going to happen by accident. Parts of it are going to be designed. Who's better at that? task than many other people, designers. So I'm afraid I'm burdening those of you who are listening who consider yourself designers. It's a burden. It's a responsibility, not only to help the future consumers think about what the future should be like, but also to help the future production system get excited about that future.
So if you had a wish list for designers in terms of where should they look to find opportunities, would it be finding opportunities for waste products? Would it be designing new delivery systems? Where would you see the biggest opportunities for designers to intervene?
I think in the world of product design, and I'm separating it from service design for now, in the world of product design, it's largely about material choice. If we choose material A rather than material B, the shadow of material A is at a ratio of 3:1, and the shadow of material B is at a ratio of 20:1. We need to be picking the materials with smaller shadows and learn those skills. There's some really cool materials out there. I have to say that in general, designers are very excited when they're finishing their degrees and they do their degree show and they've got all these amazing materials. And it doesn't take long before we're choosing from a very small palette. And I would encourage designers to go back out and to feel like that third year undergraduate designer again and go and widen your palette and go, wow, there's some fantastic, cool materials that are emerging in my sector. Maybe I just want to play with them in some corners. That will be one of the biggest things that you can do. Don't worry about low energy, because it's the energy that goes into the shadow that you're saving. So material choices, please. For service designers, that's really rather different. And in the service world, it's a combination of materials and movement that causes the environmental impact. So yes, which materials are being used? Can you substitute materials with a smaller shadow into the system that you're currently designing? But as a service designer, one of the consequences of what we do is we move materials around a lot. So when we design a service, we make people travel to a point of delivery of that service. We make people do things online. Yeah, well, online, therefore nothing's happening. No, we know that's not true. If you buy something online, the logistics of moving that around the world are a truth. That's the impact we're generating. I'm afraid for service designers, the decision is a little bit more complex because there's a trade-off between selecting good materials and selecting movement processes that work at good volume and in efficient ways. I'll give a hint about why it's complicated. If you take a classic 40-foot container and you put it on a ship in Shanghai and you move it to Los Angeles, you think, wow, that's a lot of movement, right? That's a very big ship. But there's also a lot of containers on there. When you put it on the back of a truck, by the time it's gone 120 miles, it's doubled its carbon.
Wow.
So don't worry about shipping it from Shanghai. Worry about the 120 miles becoming 240 or 480. And that's where carbon literacy to do with movement, I'm afraid, is a skill that service designers have to learn because they, in the end, design motion.
Yeah, that's really interesting. So I have two final questions for you. One is about the future of the city, the future of the sustainable city. And I think we touched about that with these neighborhood or even street level factories. Do you have any other thoughts about the future of city design?
I'm a poor engineer, not a designer, so I'm not going to come up with beautiful visions of the entirety of a city, that it'll look like a garden, or it'll be linear, or it'll be underground, or it'll look like a tree, any of those beautiful things. But I do think that we are becoming much better at understanding the social shadow of cities. So there are benefits to being in crowded places, right? We get benefits of proximity, which makes things efficient. It means that I can go to a high quality restaurant and have high quality food at a reasonable price that could never exist in a small village that I came from.
Right.
So we love those benefits, and more people will move towards cities. But the social cost, even if I'm surrounded by 20 million other people, is that I don't know anyone. So I think that we'll see as a design paradigm for cities, a recognition that most people can handle about 200 names, about 200 strong social connections. And I think that we'll see cities designed in those ways where we will have city-wide efficiencies, but delivered within systems that are human scale, and a factory that is at the end of your street where maybe 2 people work. That's the sort of scale that the future will hold. The one thing we've got to stop is significant movement of materials across the boundary of a city to the outside world. So if you look at the shadow of a city, we use this idea of shadow a lot in our conversation.
Right.
The shadow of the average city has been doubling every couple of decades. So the amount of land that's needed to support one city, if the city stays the same size, doesn't physically grow, the amount of land needed to support it keeps doubling. Well, we've now run out of that land. So we've got to learn to allow materials into cities and not allow those materials to escape cities, to be sent somewhere, to be burnt or put into landfill or wasted in some way. Once you've put the material in, the city itself has to find a way of keeping it circulating. Rather than having a relationship with the rural world that says, you are my waste outlet.
Right.
We will be the clean place and you will be the growing place and the dirty place. That has to stop because we're running out of room to be able to do that.
Yeah. A final question, which is our usual closing question. And in his TED Talk, philosopher Alain de Botton talks about the difference between a lecture and a sermon. And in his talk, he mentions the lecture as a modern, very secular way of speaking to a crowd, where you just give them a little bit of information and each person makes their own mind about what to do with it. And the sermon, he kind of wishes that we went back to having a little bit more sermons. A sermon is a more urgent and passionate plea to change someone's life, really trying to get them to see something that could really help them live better. And so my usual question for every guest is, if you had a chance to give a short sermon to people and really be understood, and it's a chance to really change someone's life, what would that sermon be?
Firstly, I think that one of the beauties of becoming a professor and the title Profess is a request to stop lecturing and start writing sermons. That's, I believe, what the system is requesting of its modern professors. And too many of them are unwilling to grab that responsibility. It's quite a scary responsibility to philosophize, to decide it's okay for me to offer my view of things that are important, rather than I'm going to hide behind the data. I'm going to tell you facts and let you make up your own view for yourself. Of course, we also still teach, we lecture, we give people facts and we let them make decisions for themselves. But if I do have some requests, I'm going to presume that you're one of 2 groups of people, dear listeners, either franchised or not. You have power or not. And if you don't have power and you are 14 years old and you're listening to this thinking we need to do something, then my request of you is to ask your parents, your aunties, your uncles, what are they doing about climate change? Just ask. Don't argue about the answer. Just ask the question. Because what I've observed is the power of that to people of a generation who don't understand the urgency. They're not going to live with the consequences. They don't understand the urgency. But once you personalize it for them, you have changed their world. Now, climate change is not something that's on the news. It's something that belongs to John or Jane. If you're the franchised group, I'd like you to imagine that your niece has asked you, what are you doing about climate change? Because it is that urgent. So please get yourself informed and do something about it. We all have some degree of agency. And the more the world sees us doing something, we become the movement.
Thank you very much.
Thank you.
All right, that's it for today. If you enjoyed the podcast and would like to support it, please consider writing a 5-star review in Apple's podcast app or wherever you're listening. It helps many more people discover the podcast and also makes us feel good. Current support for the podcast comes from my own design company, Remake Labs. We run design sprints all over the world, and our goal is to improve outcomes, whether in business or various organizations, through repeated and rapid design interventions. Now, until next time, be well, everyone. See you next week on Remake.